Hello everybody. This is part 2 of the kinematics derivation video. I just proved that V equals V naught plus AT using the expression A equals dV dt. So we started the entire process with A equals dV dt. That is a really thick marker. And then we integrated it again, so we arrived at both this expression and that expression. Reminder, this is for a condition where we're in one dimension, the acceleration is a constant, and at the initial conditions, our initial velocity was v0 and initial position was x sub 0. I'm going to rearrange this guy here and solve for time. So v minus v naught equals at, which means the expression t equals 1 over a times v minus v naught. All right, and then we're going to take that expression and put it into this one. X equals x sub 0. So this is calculus, algebra. The calculus is over at this point. Plus v naught times quantity, and we've got v minus v naught, and then there's the 1 over a. We don't want to leave that out. And then plus 1/2 a, and the t squared is now v minus v naught squared. And again, we don't want to leave out the a. 1 over a squared. All right, now would be a good time to point out, you certainly don't have to do this, but one of the most common ways to see this is the expression for distance. And you certainly could say that x minus x sub 0 is delta x, which is usually the value d. So we could use that to sort of simplify this a little bit. If I move the x naught over to the other side here, now I've got delta x equals. So more familiar format. We could also put it as d equals, okay? Which means now let's go ahead and distribute this. So v0v minus v0 squared times quantity, 1 over a, leaving that guy in there, plus 1/2 a, and let's square this, v squared minus 2v v sub 0, and let's finish that instead of just closing the parentheses. So that was v sub 0 plus v sub 0 squared, and I don't want to leave out my a squared again. Okay, cool. So most of the time we use the expression d, but sometimes you see delta x. So let's go ahead and use d for our final answer, mainly because I'm used to saying vf squared equals v naught squared plus 2ad. Okay, cool. So we need to simplify this somewhat. It's probably worth noting, let's cancel those guys there. So now I've got a 1 over a here and a 1 over a there. Let's multiply both sides by 2a. So 2 times a times d. I'm not use this guy, I'm use this guy. So when I do that, now I've got 2 here times v0v minus v0 squared. My a is now gone. Plus 1/2 v squared minus 2v v naught plus v naught squared. And the a is now gone. Oh wait, my 1/2 is gone too. There's no one here to check my algebra. Only me. That is terrifying. Alright, I do have notes, so let me just check, make sure I'm in the right place. Looks good so far. Okay, so we can simplify this a tad. So now we've got 2 v naught v minus 2 v naught squared. And we've got v squared minus 2v v naught plus v naught. Alright, wait, this was squared. I lost my squared from here to there. So now these expressions look right to me. Alright, so 2v naught, 2v naught, and negative 2 v naught, these cancel each other out. And so this is 2ad, and now we've got negative 2 v naught squared and a v naught squared over there, so that's v squared minus v naught squared. The more familiar format here is to move the v naught squared to the other side, so that v squared equals v naught squared plus 2ad, and very often, much like we have with the other ones, it is often written with a little subscript f for final. Vf squared equals v naught squared plus 2ad. All right, so the expressions that you definitely have to remember: v equals v naught plus at, x equals x naught plus v naught t plus 1 fat squared, vf squared equals v naught squared plus 2ad. The expressions a equals dv dt is really the heart of this entire enterprise that we've just done, so that's another one I'll box. And velocity is dx dt. So there we go. 1, 2, 3, 4, 5.